My name is Daniel, and I'm going to talk a bit about coordinating asynchronous operations. I only have 30 minutes, and I prepped this really well for several evenings, just crunching it, so hopefully we'll make it in time. The agenda is going to be first defining the actual problem with asynchronous operations, which I'm sure that most of us in here know about. Then, look at some third-party libraries that aims at helping you with this. Look at a real-world case study from the place where I work, and then a live coding session. Always exciting. And then finally, I've written about this, I've blogged about this, and I wrote about it on CocoaHeads, and I just had it as a transparent, humiliating format kind of thing, like throw out ideas and like Jack, getting feedback back that this already exists. So I love for you to shoot this down and ask questions and help me evolve this idea. So it's not something that is set in stone. So the problem definition. You didn't know this, right? Coordinating asynchronous operations can be tricky. So unless you're just calling in an API, waiting for half a second, 2 seconds for a reply, and then operate on that result, it can be pretty tricky. You can have serial operations that you have to run in sequence. You can have concurrent operations that you need to synchronize when they return values from. So it can become nasty. And in my opinion, but I'm perhaps too unexperienced, I think the native support is pretty limited. We have completion blocks. I don't know, I don't think really it's not enough. And we have Grand Central Dispatch, of course. I don't know anything about that. A little bit about it. But I don't think that we have the tools we really need. We need more sophisticated ways. And I'm not alone in thinking this. So a lot of people smarter than me have created a bunch of libraries to work with this. We have one library called PromiseKit, which, how many of you have worked with promises? So, yeah, a few of you. So basically, if you use PromiseKit, instead of having completion blocks, your asynchronous calls return an object, a promise, that can either succeed with a future result or fail. So here we see that no chords, I can walk around freely. Yeah, nice. So firstly, we make this asynchronous request, the first one. Then, when that is done with a result, we can perform our next operation. And then we can use the result from the first operation and yada, yada, yada. And if any one of these operations fail, we can catch the error and life is happy. But although this is easy, I think that you still have a lot of blocks. This is like completion block deluxe. So, and it's also pretty chatty, like firstly do this, then do that, blah, 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 blah. So, since I'm a full stack developer, I worked with C#, and I worked with JavaScript, and they have something called async await, and that's amazing. This code is not amazing. So basically, with async await, you get a new keyword that is await, and this code is basically this code. So the first asynchronous request gets awaited, and if you try bang it, maybe you get a result back. So this is really nice. It reads like synchronous code, and that's amazing. But this is the official docs, like use try bang. That's great. I love AwaitKit. I think it's great that the guy who did it, but I don't think you should do it like this. I think you should perhaps do some do-catching stuff, and then life will be happy again. But my biggest concern with this is that if I wanted to use this in my apps, it's based on PromiseKit. So you get 2 dependencies for the price of 1, although you don't use one of the dependencies because you have a wrapper around it. So yeah, pretty nice. I hesitate to use it. Now we have RxSwift. Lovely Rx. Everyone who knows programming loves Rx. And everyone who doesn't know Rx pretends to know it. So this is a really powerful, I don't even know what the name is, but you do something here. You Rx, the search bar text, and you throttle it for 0.3 seconds until you have a distinct change. Then you flat map the latest, and you do a search GitHub thing with a query. And perhaps I'm just stupid, this is very powerful, and it's not just like do asynchronous stuff and handle the result. You have streams, I think, data value streams, you have bindings and stuff. Amazing, but this is a major commitment. If you make an Rx app, I think you should make an Rx app, and you and your fellow developers should know everything there is to know about Rx. Then life will be happy. But the conclusion that I came up with when I started to work with asynchronous operations for the 100th time was that a lot of people have worked with this for a lot of time. And there are a lot of great libraries out there. Many are very powerful, but many will affect your architecture. And sometimes, although third-party libraries are great, sometimes they're not the best tool. So, case study. I work at a company where we stream audiobooks and ebooks, and you can read books, and you can listen to books, and you can do stuff with books. And we have extensive offline support. So if we present you with a view with a lot of books, even if you drive into a tunnel, or go with the subway into a tunnel, or walk into a tunnel, or do something in a tunnel, if you lose your connection, partially or completely, then everything you do with the data you see, like you can save books, you can remove books, you can rate books, you can, I don't know, share books perhaps. It's a book app, so you can do a lot with books. We store everything you do away. And if you have downloaded a book and you listen to it while you're offline, we save all the bookmark mutating information as well. And we also track our users. So if you tap a button, we know about it. But we won't know about it until your app comes back online, because then we sync everything we have, and once the syncing is done, we pull the latest data from the backend, and the app is in sync again. So pretty basic and pretty hairy, because this is a simplified version of what we actually do. So book actions for us is something you do with a book. It's an action you perform on a book. It's pretty complicated, but that's the way it is. So if you rate a book, if you save a book, if you remove a book, we have all this action handling in place, and we store them away. When we come back online and we want to sync them, we can't like put them together in a big bag and send them, because we don't have backend support for that. So we have to send all these actions one by one in the order of execution. So if I save a book and do something later that has a side effect that removes the book, they need to happen in sequence. So one by one, serial. And the bookmark information, there we have timestamps, and we have batch support from the backend, and everything is amazing. We can just take all our progresses, chop it up in chunks, and just send all the chunks away, and the backend just eats the data, and then after a while it says you're done. And then we have analytics. A bit like bookmarks, we can batch it up, we can send it off, we can eat it up, and we can do it concurrently. The big difference with bookmarks and analytics is that analytics is just data for making the app better. We don't really care about if it arrives or not, but the bookmarks is super important. So this is actually also the sequence. We first have to synchronize all the actions sequentially and wait for them all to complete. Then we sync bookmarks. But we can also start sending analytics whenever, and we don't have to wait for the result. And then once the first ones, the actions and the bookmarks are done, we can fetch data from the backend, and we do a lot of more sophisticated stuff as well. But this is the big strokes. So the problem here is, for the various actions we have completely different asynchronous needs. And some operate on items, item per item. Some operate on batches. Some are serial, some are concurrent. Most must be coordinated, others can just run in the background and finish whenever. So we have to find a way to do this, and given our architecture, we don't want any third-party dependencies, because we have microservices. That's amazing. No, we have many small frameworks where the model is one and the domain is one. So the model is books, bookmarks, users, stuff. And the domain is how you operate, how you work with model. And if we were to add PromiseKit or AwaitKit to the domain, then all other frameworks that have dependencies to the domain would get these dependencies as well. So for us, it's not an option. So the approach that I had was to take this on as a fun modeling challenge. Like, how can we describe our needs as protocols? How can we find a good way to compose this together? And how can we use extensions to add functionality to our protocols? Daniel? Oh, there. Nice. But we also need to have these protocols being composable and customizable for the architecture. So that was an approach. I took it on transparently in the community. I was shut down a couple of times. I think I ended up in a pretty happy state. And also, being this solid kind of guy, I want composition over inheritance. So no classes where protocols will suffice, classes where it makes sense. So, if you go here, bring up your, no, computers, okay. If you want to take a look at this code later, this is where you can find it. I'm going to live code, and then come with some conclusions. So if, oh, spoiler alert. I have a super simple view controller. It can create items and operations and print, and you don't know what that is until I show it to you. This is the beautiful app. It can perform operations, but it doesn't do anything right now. So when I started this modeling task, I looked for the most basic description of an operation that I can come up with, and I think I nailed it. This is an operation. You can perform it, and it can complete with an optional error. And now we're done. Bye. So this is nice. This is an abstract, anonymous operation. And if I were to implement this in a demo kind of way, I could create one with a name and a printer of sorts. And when I perform it, I just print that I'm performing the operation. I go into background mode, I sleep for a little time, then I go back to the main thread and I print finished. It's really complicated. If I were to implement this, I could say let op equals demo operation, like that, name foo, perhaps, and the printer is the view controller, so this is a really nice architecture, like that. And if I were to say perform here, I could just say print self.print, like that. And if we now run it and press perform, perhaps, hopefully, something will happen. Boom, we're done, I think. Okay, so this is like the most basic thing. We can actually build stuff with this, but it doesn't really do much. So, for instance, consider that I have operation 1 and operation 2. Name? Yay! Okay, I promised myself not to do that. So, operation 1, perform, and then say operation 2, perform, like that. Now we have a serial operation queue. Yay! So, this is amazing, right? Really powerful stuff. Now, if we want to perform this concurrently instead, we have to perform operation 1, and then we have to perform operation 2. We have to somehow in here find a way to coordinate both. And this is where I found the need for the next concept, a coordinator. So the most basic way to coordinate operations would be to have an operation coordinator protocol that performs operations, like that. And then, with that in mind, with this in place, we could create a concurrent coordination very easily. So basically just take a bunch of operations, check that we actually have any operations, otherwise just complete. Create like a container for the optional errors that we will receive. For each over everyone, perform them, and we complete when we have received as many optional errors as we have operations, and then we're done. So if we want to use this, we could just uncomment a piece of code here and take a look at this code. Is the font size okay, or do you want it bigger? Okay, cool. So here we create 5 operations. We create a coordinator, and then we just ask the coordinator to perform the operations. And when it's done, it just finishes out how many errors it's received. The answer is 0 in this demo. And if you remember the demo operation, it's going to sleep for a variable amount of time. So that simulates the real life with a network connection. So the operations will fire off in the given order, but they will not complete in the given order. So now, if we send this off, you see that they arrive as they want. You have no control over it. But we have control over like the synchronization when we received everything back. So this is nice. I mean, this is a concurrent operation coordinator. It's not really magical. It's super simple. And we could create a serial version as well, where we just perform at index 0 with an empty start array. And then we just operate on the first operation, wait for it to complete, store away the error that we receive, and perform the next and the next and the next. And if we want to use that, we can just replace the concurrent operation with the serial one. Run that. So in the concurrent case, they all were fired away at once, and they slept for about the same period of time, and then they completed about the same period of time. And this just waits and ticks them off in order. So this is, I mean, I'm not going to be a rocket scientist, ever. This is super basic. But I took a step back when I had this in place, because anonymous operations like this is not really useful for the actual operations that we want to perform. It's good to perhaps describe like sync bookmarks, like an anonymous operation like that. But under the hood, we need to have more control over how we do stuff. And when I looked at all the operations that I mentioned to you, like book actions and bookmarks and analytics events, it's collections of data, collections of stuff. So if we take a step back to the operation, we could describe a new kind of operation that operates on a collection instead. So for this one, you just specify the type of the collection, and you have a function that is called perform on collection instead. And what we need to complete this is to look at, if we start to look at the case of book actions, we perform our operation on every item in the collection, right? So we could describe that as an item operation, which is a collection operation, but you also need to define how you perform the operation on a specific item. And if we were to stop here, we would at least, unlike the situation that we had previously, we would have a common language of how to talk about our operations. We could say that, yeah, synchronizing book action, that's an item operation because this and that. And doing the bookmark thing, yeah, we haven't come up with that concept yet, but I think we're going to get there soon. But at least we would have a language to speak about. But if we wanted to actually do some more leg lifting and help ourselves out a little bit more, we could create a more specialized version of the item operation protocol and create a concurrent version of this, which is also a protocol. But if you implement this, you would actually get the coordination in a concurrent way. And as you can see, this code looks a lot like this, so keep that in mind. We're going to get back to that. So now, if we implement concurrent item operation, then we just have to implement this function. So we can take a look about that. So in the demo, we have a demo item. It's just nothing. It's just an ID. It's nothing special. And then we have an item operation. It's just the same operation as before, but with some more sugar on top. So it is a concurrent item operation. But the only thing that it has to do is to define the collection type, which is demo item, And then it can perform on the item. And now it just performs as before. So if we look at that in action, you can see that we once again create 5 items, but now items instead of operations. And we create this operation of ours, and we ask it to perform on the collection instead of just performing. And that would end up with the same result as before. We have 5 items that are triggered at the same time, and they complete in random order. So this is a lot more, at least for us at BookBeat, a lot more useful. And we can also create a serial implementation of this, which looks almost exactly like the coordinator from before. And now, since this concurrent one and the serial one are both collection operations, we can just go back to our demo operation. And if we want to make this serial instead of concurrent, we just have to replace the protocol that it implements. And now the operation will be serial instead of concurrent. Like that. So now I think we have the book action handling wrapped in a bag. We have an anonymous operation that can say, do stuff with, perform stuff with the book actions. And then under the hood, it can use these other operations and coordinate stuff, really fine-tuned. But we lack something for the book progresses and analytics events, and we send them off in batches. But the implementation details are really similar to the item one. But instead of an item operation here, we can have a batch operation instead. And what you have to define then is a batch size, of course, and you perform on batch, which is like a subset of the collection that you operate on. So if we look at an implementation of that, we can see that we have demo batch operation with a batch size of 2. And just like the item approach from before, we can have a concurrent batch operation, which starts by batching up the collection with the given batch size. And then it just iterates over the batches instead of over the items. And we have perform on batch instead. So now we have a big pop quiz here. If we have a demo batch operation with a batch size of 2, we go over to the batch. And the example uses 5 items. And it uses the demo batch operation to perform. How many times will this operation perform? We'll see. So it's going to chop it up into 2 items, 2 items, and 1 item. So when we perform this, we get 3 batch operations that finishes in random order. And since we use the same approach as before, the serial batch operation is very similar to the item one. And we can just take the demo batch operation, switch out the protocols, and we have composed ourselves a new kind of synchronization model. So when we run it now, we're going to have the serial execution like that. So now I was like ready to pop the champagne, and I'm done. Like 15 years of hard work, and I'm finally done. But then I was not really happy with the coordinator thing, because if you take a step back now, this is like this, I don't even know the name of the movie, but you start with something and you end up with something that gives you something, a feedback loop to the first thing, and then you're, yeah. So I hope that you can follow me around here, because this is kind of confusing. But when I looked at the operation coordinator, it's something that performs operations, like a collection of stuff. So basically, the concurrent operation coordinator is a collection operator of item type. So it's still a coordinator. We still have to use it as a coordinator. That's the external usage of it. But to make the implementation a lot easier, we could just go back here. Sorry. Say that it's also a concurrent item operation. And then the code just becomes this. The operation coordinator protocol is perform operations. The collection operations protocol is perform on operations. And the item protocol is perform an item. And since we already implement concurrent item operations, which provides us with the execution plan, we just have to do this. And the same goes for the serial one. Actually, these become identical. So they just implement different protocols here, like that. So this is no silver bullet. Wait, I'll go into conclusion mode. There we go. I almost spoiled it last time. So this is no silver bullet. It's a custom-made approach for us. And in our code base, it's probably going to mutate into something that fits our need perfectly. But I think that it's a super simple approach to working with asynchronous operations. And it doesn't really have to be that complicated. I was considering making it an open source library, but that was just, don't use third-party dependencies, build it yourself. If you want to grab the source code and play around with it, you can go here. Otherwise, I'll be happy to discuss this and answer questions and stuff like that. So, yeah, I don't know if we have time. Thank you very much.
We do have time. So we got a question right here to start off with.
Great presentation.
Thank you
I
very
really
much.
like the usage of foundation basically and everything. One small question: all of the operations finish with just an error, and a lot of libraries that have asynchronous handling usually return a result type or something similar.
Yeah.
Have you thought of maybe using something like that? And if you decided not to, can you kind of elaborate more on why?
Yeah, basically this is, as I said, our needs is going to shape the architecture of this. But for instance, the operation that we have can have a result type, of course, and provide that. I also considered now you end up with an optional, a collection of optional errors, but that probably it's nil over there. It's not really that useful. So I think this is just like a first draft, and yeah, we also like the functionality. We don't have any any ways to cancel ongoing operations. So this is just do this. I don't care, and we have no chance of interrupting or intersecting. So it's real primitive, and it probably needs a lot more functionality. But we're gonna add it as we find a need for it, basically. If that makes sense.
Yeah,
cool. Thank you.
Got a question over here, right?
Yeah, just an add-on.
Yeah.
Yeah, I had just a basic same question, and our problem here is that if you return results, then you can have this kind of first two operations or functions create some results, then the third one should do, and the fourth one should use the result, and then you transport the result of the first two or the first one over the context of the second and third into the fourth without too much noise and code clutter, and that's the really trick problem.
Yeah.
That gets very difficult in Rx, or I mean very verbose.
Yeah.
And so I'm looking forward to a way to solve this in a neat way to sort of dependencies in results.
Yeah. So basically, the idea that I have for this is that this is going to be building blocks for compositions that actually do stuff. And for instance, we can have a bookmark synchronizer, for instance, that is an operation that is anonymous, but it also has more information. So by using the operation protocols and talking this language, we get a lot of functionality and logic for free, but then we can add more. So the bookmark synchronizer can have more contextual information that you need. And you can chain that by doing that first, since that is an operation. It's going to complete, and it can use whatever mechanisms inside to synchronize the execution. And when that completes, it can have information it needs. So now we just have error, we failed 55 times. Go play. But we could build it up like that. So that's my idea about this, to actually let the implementations provide more stuff. But also with Swift, we're going to get this result type with an error and result. So perhaps the language will help me out in Swift 5. Let's hope. Pray to God.
Did you consider using NS operation and NS operation queue in Foundation?
Yeah, I read up on it, and like the GCD as well. I think that you can perhaps, I like the modeling approach of this, like to actually describe what you want to do, or what your domain needs are in protocols, but the implementation could use that as well, instead of having this for loops that I use. Yeah.
Yeah, thanks for a good presentation. It was a nice foundation, and as I understood, you plan to use it in your project, right?
Yeah.
So could I ask you to make some follow-up in next year to see where would you grow? Would you come with schedulers to process it in different threads, and how you would do retry mechanism and stuff like that? It would be really nice to see.
Are we still in business?
Yeah.
It's just a burning house on Sveavägen. Yeah, I'd love to. If you want to hear more about it in a year, see me cry on stage, I'll be happy to return.
All right, thanks.
Thank you.